Welcome to the Explainer. Today, we are diving into a piece of math that is seriously everywhere, from the graphics in your favorite video games to the GPS in your car. We're talking about coordinate geometry, which is this really incredible idea of turning shapes and spaces into actual numbers you can crunch.
So let's kick things off with a little puzzle. Imagine you have a map and you need to find the exact distance between two towns. You don't have a giant ruler and you definitely can't just walk it. So how do you figure it out? That question right there is the key that unlocks this whole topic.
Okay, so here's what our puzzle looks like. We've got town A, that's our starting point, our origin, and town B is 36 kilometers to the east and 15 kilometers to the north. What we need is that straight line distance, the as the crow flies path. This is the perfect example of what coordinate geometry does. It takes a problem you can see, a geometry problem, and turns it into a math problem you can solve. To solve this, we've got to first understand the fundamental tool that makes all of this possible. It's called the coordinate plane. Think of it as a map made completely out of numbers. Let's break this down. The coordinate plane is just a grid, right? It's made by two lines that cross. The horizontal line is the x-axis and the vertical one is the y-axis. Now, every single point on this grid has its own unique address, which is just a pair of numbers, an x, y coordinate. The x tells you how far to go left or right, and the y tells you how far to go up or down. That's it. It's like a perfect filing system for, well, every point in existence. So now that we have our map made of numbers, let's build the ultimate ruler. I'm talking about a formula that will let us measure the distance between any 2 points on this map, no matter where they are. Measuring along the grid lines is super easy. If you're going straight across, horizontally, you just subtract the x values. If you're going straight up and down, vertically, you just subtract the y values. Simple. But what about a diagonal line? Like our path from town A to town B. Yeah, you can't just subtract the coordinates anymore. So what do we do? Well, the solution doesn't come from some super complex modern piece of math. Nope. It comes from an idea that's been around for over 2,500 years. Any guesses what it might be? That's right. It's our old friend, the Pythagorean theorem. You definitely remember this from school. A squared plus b squared equals c squared. It's the perfect tool for finding the length of the longest side of a right-angled triangle, which is called the hypotenuse. And here is where the magic happens. We can take any diagonal line on our grid, connecting any 2 points, and we can turn it into the hypotenuse of a right-angled triangle, just by drawing a horizontal and a vertical line. The length of that horizontal side, it's just the difference in the x-coordinates, and the vertical side, just the difference in the y-coordinates. So when you see this formula, don't let it scare you. This is literally just the Pythagorean theorem dressed up in coordinate geometry clothes. We take the horizontal distance, the change in x, and square it. We take the vertical distance, the change in y, and square it. We add them together, take the square root, and bam, that's our distance. This is our ultimate ruler. It works for any 2 points, anywhere on the plane. All right, now for the fun part. Let's see how this one formula lets us solve all sorts of geometric puzzles using just pure calculation. No drawing required. Okay, picture a classroom. You're given the coordinates for where 3 different students are sitting. Can you tell if they're all lined up perfectly, just from those numbers? With the distance formula, you absolutely can. So check this out. We have Ashima at point A, Barty at B, and Camilla at C. We have their exact coordinates on the classroom grid. Now, to know for sure if they're in a line, we can't just eyeball it. We need to prove it with math. So here's the logic. It's pretty clever. We use our distance formula 3 times. First, we find the distance from A to B, then from B to C, and finally the total distance from A all the way to C. Now, if the 2 smaller parts add up perfectly to the length of the whole thing, they have to be in a single straight line. And look at this. 3 root 2 plus 2 root 2 equals 5 root 2. It's a perfect match. They're in line. And we can get even more complex. What if you want to know if 4 points form a perfect square? Well, you just use the distance formula again. First, you check if all 4 sides have the exact same length. But that's not quite enough because that could also be a rhombus, right? So for the final check, you also measure the 2 diagonals. If they are also the exact same length, then you've mathematically proven it's a square. Pretty cool. So we can measure lines, no problem. But what if we need to find a specific point on a line? A point that splits it up in a very specific way. For that, we're going to need a new tool.
Let's go back to our towns for a second. Imagine a phone company needs to put a relay tower on the line connecting town A and town B. But here's the catch. It has to be placed so that its distance from town B is exactly twice its distance from town A. That means this tower divides the line in a 1-to-2 ratio. How in the world do you find the exact coordinates for that tower?
This is the section formula, and I know it looks a little intimidating, but the idea behind it is actually really elegant. It's just a weighted average. You're taking an average of the coordinates of your two endpoints, but you're giving more weight to one of them, depending on the ratio you need. And there's a really useful special case of this for finding the midpoint. When the ratio is exactly 1-to-1, meaning you want the dead center of the line, the formula gets incredibly simple. You just add the x's and divide by 2, then add the y's and divide by 2. It's just a simple average. Super easy. Okay, let's just take a step back and appreciate what we've just uncovered here. This isn't just about learning a couple of formulas. This is about a completely new way to think about shapes and space. You've essentially just gained two new superpowers. The distance formula is your ultimate universal ruler, and the section formula is like your precision-guided tool for placing points anywhere you want. With these two, you can translate almost any question about distance or position into an algebraic problem that you can just solve. And that really is the mind-blowing power of coordinate geometry. It's the secret bridge between the visual world of shapes and the logical world of algebra. It lets us analyze, prove, and build things with a precision that just drawing and looking could never give us. So the real question is, now that you can turn any shape into numbers, what will you explore? Thanks for watching.